this lesson. Okay, we're literally looking at the 4 rules and the 4 arithmetic operations. So let's start with sums. Starting with sums. Can somebody just simply read the first rule and then maybe discuss what's happening in the first rule? Discuss, Julian, what's happening once you read it? Go ahead.
If A and B are negative, then A plus B is negative, and A plus B is equal to negative the absolute values of negative A plus B.
So when we look at this example here, when you add 2 negatives, you're going to get a result that's also going to be negative. That's common sense. I think we know that. A negative plus a negative is more negative. Negative times negative is not the same, obviously. What about this last piece here? And if they're both negative, we could say A plus B equals negative quantity, absolute value A plus absolute value B. What's going on there? Clark, tell us about this.
They're taking the negative A and B, and since it's absolute value, they're going to turn it into positive A and B, and then they're multiplied by the negative, which just repeats it. So then they're both negative.
Well done, Clark. So what Clark is saying in a nutshell is this. Take a look at adding these 2 numbers together. Just add them together as if they're positive and then tack on a negative. That's exactly what Clark just said in simpler terms. Good job, Clark. Good explanation. Okay, so again, think of this as negative 3 plus 4, which is really negative 7. All right? And you keep factoring out the negative 1 is what it's saying. And these are the absolute values of the original numbers here. And you get 7, tack on a negative. The second part, please. The second part. Volunteers I'm asking for. Volunteers. Gus, go ahead.
If A is positive, B is negative, and the absolute value of A is greater than the absolute value of B, then A plus B is positive.
Can you simplify or give us an example of this, Gus, that would maybe help us to prove this true? So just follow the rules. Give me a number for A. That's positive.
Okay, so 3.
All right. Make B negative.
Negative 3.
But A has to be, remember, read this rule too.
Oh, right. Negative 2.
Good. That's true.
And then, yeah, so then 3 minus 2 is 1, which is positive. And the absolute value is 3, and the absolute value of B is negative 2, which is 2. So then 3 is greater than 2.
Yeah, so pretty much what he's getting at is like, hey, if I've got 2 numbers that I'm adding, if the bigger one in magnitude, do you know the word magnitude? Magnitude is the value itself without the sign. Absolute value, magnitude, same word. Absolute value, magnitude, same word. If the magnitude of one of the numbers that is positive is bigger than the magnitude of the negative number, when you add them, you will always end up with a positive number. And you know this already, but I don't think you've seen it written this way yet. Okay, that's why I'm trying to introduce you to notation. In math, in middle school, you learn a lot of stuff that you repeat in high school. But when you get to high school, you start saying, let's not use numbers anymore. Let's write everything in variables. So that second statement that's bulleted is all variables, but this in red is the example of it. Okay, and now, how about the third bullet? What can you tell me? Don't even read the whole thing, just tell me what the third bullet is getting at.
So, pretty much, let's say A is 2,
Uh-huh.
B is negative 5.
Uh-huh.
When you add that together, the answer is a negative 3.
Very good. So what happened there?
So
Just compare it to the previous bullet.
So instead of the last bullet where the A is greater than the B, and the absolute values of A is greater than B. This time the absolute value of B is greater than A, making it a negative.
Correct. So it's the opposite of the last example, right? If the bigger number is negative and you're adding 2 things together, the answer is clearly negative. Clearly negative. But we need to be able to read mathematical notation that's written like this. That's written with bullet point, not with the bullet points don't matter, but written the way it's written here, I'm saying, with these bullet point statements. Okay, you have to be able to understand what's actually written there. Questions on sums. That's it for sums. That's all of section 1.4 right there. Okay, that's what I'm saying. There's a lot of review in the very beginning. Differences? This is it. That's the only thing we need to know for differences. That's it. Okay? Subtraction is defined as adding the opposite. That's all it is. That's all it is. Try it with any numbers. Okay? 7 minus 3. Well, that's just 7 plus negative 3. And based on my addition rules, which of these has a bigger magnitude? The positive or the negative? Positive. So what's my answer going to be? Positive. 7 minus 3 is definitely positive. Okay, this is a very important definition, even though I know it sounds trivial. It is actually very important, especially when it comes to variables later on. There are times where you want to add negative instead of subtracting. We'll see when that comes up. That's a good definition to know. Questions on differences? Pretty much the same as sums, right? No difference between different sums. Products. We'll do products and then we'll do quotients. Products, a good amount of rules here. So let's do this again the same way. You can read a rule and then explain it to the class. Read a rule and then explain it to the class, maybe with an example if you'd like to, right? First name again is Sean.
Yes.
Yes. Okay, good, Sean.
Product of two positive values and two negative values is positive. For example, well, if you multiply two, I'll just use a square as an example. So if you square 8,
Okay.
it will always be 64.
Okay.
And if you square negative 8, it will also be 64, because if you multiply a negative by a negative, it will.
I like the example you gave. Very good. Okay. Any number squared is always going to be positive. Is exactly what he's getting at, with either 2 positive or 2 negative. Well done. And again, they don't have to both be 8. It could be 7 times 6 or negative 7 times negative 6. That's fine. Second one, Jimmy, go ahead.
So this one, I explain it first, or just?
Sure, and give an example. Read it maybe and then give an example.
Okay. The product of positive and negative value is negative. This is true. 2 times negative 2 is negative 4.
Very good. Okay, anytime you multiply positive and negative, you'll get a negative answer. These are things you learn in like what, 4th grade, 3rd grade, right? It should be real easy refreshers. All right, let's get some more tough stuff. Third one. Yeah, the first two are very easy, I know. Third one. Read through it, make sure you understand it. If you do, then give volunteer to give an explanation. Olivia, go ahead.
For example, the absolute value of 2 times 3 is 6, and the absolute value of 2 is 2, and the absolute value of 3 is 3, so 2 times 3 is also 6.
That works. Can you give me an example with negative numbers also?
Yeah, so negative 2 and negative 3. The absolute value of 2 times negative 3 is also 6, and then the absolute value of negative 2 is 2, and negative 3 is 3. Negative 2 times 3 is also 6.
Hold on. So positive or negative, it does not matter, right? If we're multiplying something with an absolute value, when there's factors inside, that absolute value can be taken for each factor. That's what I'm getting at here. So if I did something like this, let me just move over for a second. I'll put it back. So if I had something like this, the absolute value of x times y times z, I could write it as x times y times z all separately. Okay, it's the exact same thing. It works for infinitely many factors. Property of zero, simply put, John, go ahead.
So basically, property of 0, a times 0 equals 0, where a is any real number. So basically, any number, a negative or positive times 0 is always going to be 0.
Exactly. If I want to know 7 items twice, I get 14. But if I have 7 items 0 times, I have 0 items. See what I mean? Like if you think about it that way with physical quantities. If I say I have stacks of 7 and I have 4 of them, that's where 28 comes from, right? 4 stacks of 7. But if I have 0 stacks of 7, do I have any items? No. That's where the zero product property comes in. Next one, property of -1. Property of -1. What's going on here? Julian.
Property of negative 1 is basically any real number, a number above 0 multiplied by negative 1 is negative 1.
Good. So it's simply the same number with a negative sign. That's all it is. Anytime we multiply by -1, the value, or the magnitude of the number doesn't change, the sign changes. So if I take a negative number and multiply it by -1, it becomes positive. You're just switching the sign. And the last one. Okay.
A product of non-zero numbers is positive if the number of negative factors is even and negative if the numbers of negative factors is odd.
Can you give examples, Sean? Because an example would be best for this.
Okay. Okay. So let's say we have 4 numbers.
Okay.
2 times -2 times 2 times -2. So we have 2 negative numbers, which is even. Therefore, 2
times negative 2 times 2 times negative 2 will be a positive number.
Very good. What about the other case, Sean?
Remove the last negative 2, and then we will be left with negative 8.
Hold on. Does everybody see that? Right? We've done this before. Same thing goes on forever. If you have 3 negative numbers multiplied, the answer is negative. 4 negative numbers multiplied, the answer is back to positive. It goes back and forth based on the number of negatives you have as a product. Questions on this last rule? Good. Take us in the path that I was hit, was that? Quotients here. Let's take a look at quotients. First one is probably the most important one, actually. Okay, the definition of division comes up a lot. Just read through the first one. What do we got? Go ahead, Jim.
Okay.
Yep.
Division is defined as multiplication by a reciprocal. Note that since 0 has no reciprocal, division by 0 is not defined.
If you ever wondered, remember your teacher always says you can't divide by 0. It's undefined, he called it. Or they say it's a non-real or undefined real, or indeterminate is another word. This is the reason for it. Because there is no reciprocal to 0. What is 0, guys? What's 0 over? Tell me, what is 0 over? Okay, 0 is over 1, you think, right? But what's 0 divided by 2? Isn't it still 0?
Yeah.
What's 0 divided by 3? Isn't it still 0? So if I take the reciprocal, which one is it going to be? Is it going to be 1 over 0, 2 over 0? See what I'm saying? So there is no reciprocal by definition to 0. So that's why when you put these, you can't divide by 0. There is no reciprocal, and division is defined as the reciprocal of multiplication. Or multiplying by the reciprocal. The second bullet point, pretty much the same. Do the second and the third one together. Who could do the second and the third one together for us? It's the same as multiplication, really, right? The same as multiplication. Go ahead, John.
So the quotient of 2 positive values or 2 negative values is positive. So basically, you have 4 and 2, it's going to be 2. And if you have negative 4 and negative 2, it's still going to be 2 because 2 negatives gives you a positive.
Okay. And the other one, John? Go ahead. Keep going.
The quotient of a positive and a negative is negative. So negative 4 and 2, that's going to be negative 2 because you only have 1 negative.
Very good. Okay? It's very similar, actually, right, to the last rule of the multiplication setup. When we have 2 negatives, it becomes positive, but an odd number of negatives becomes negative. And the last and final rule for today, perfect timing, we'll have minutes to talk. Last and final rule. What's the last and final rule pretty much getting at? What's the gist of it? How would you explain it? Ian, again. So give me an example, Ian, go ahead.
6 plus 4 over 2 equals 6 over 2 plus 4 over 2.
Okay, same thing as if she had just added these together first. And 10 over 2 is indeed 5. Very good, Ian, a good example. Okay, so we can see that clearly we can break up a denominator if the denominator is a monomial. That is very, very, very important. If the denominator is a binomial, well then you would have like x plus 2. X plus 2 is to divide into this, and x plus 2 has to divide into this. You got to take the whole denominator and divide it into every single term in the numerator. Okay, every single term. By the way, terms in the numerator, 6 is its own term, 4 is its own term. Terms are separated by plus or minus signs. And not, God bless you, not multiplication signs. Right? We clear on that? God bless you. So just to reiterate what I said there, if I had 2x plus y all over x, 2x is one term, y is the other term. Now, if I specifically look at 2x and forget the y, 2 is a factor and x is a factor. So in this problem, I can break this into 2 pieces like we just showed. And then the 2x over x just becomes a 2, and the right-hand side still remains y over x. Is green? Green is not a good color in here, huh? It's 2, yeah. I'll change that next time, sorry. You see what I'm doing? The x divides into here, it's a monomial, and it divides into the other term, which is y. Y divided by x cannot be simplified. But 2x over x, the x is canceled, and that will be 2. Yes, say it.
That doesn't have to do with the rules, rather
that what you're talking about? Yeah, it's a plus or minus sign. So when you want to write a general rule that applies to both addition and subtraction, and you don't want to specify which operation it would be, because it could be either, you put what's called a plus or minus sign. It just means that if it's A plus B, the answer would have a plus. If this were a minus sign, the answer would have a minus. Yep. It's a plus or minus sign. It's used for like a two scenarios. Yeah. Shoot.
So, for 1.4 and 1.6, should we do that also?
Correct. Yeah. So, guys, this will take you a matter of, I'm not joking, probably 5 minutes. It's multiples of 4, multiples of 5. They're really quick. It's properties of adding, subtracting, multiplying, dividing. So although it looks like a lot, I promise you it's really not. Okay, so you're going to do the homework for 1, 3, and you're going to do the homework for this over the weekend. So when we come back next week, we can do 1, 7, 1, 8, 1, 9. We have to do those 3 sections still, and then we have a review day on Thursday, and then we have a test on Friday. And I know we don't meet on day 1, so 1, 7, and 1, 8, 1, 9, we're going to have to do those 3 sections in 2 days really. But 1, 8, 1, 9 are pretty much the same section. Word problems, okay, word problems. Jimmy.
Do you have a textbook here? Because I'm not going to.
There's one right there, yep. And there should always be one in the library, Jimmy, but there's one here. But I also put chapter 1 in your drive. Look at your drive folder. Open your drive folder real quick.
Okay, we have it?
Yeah, it's in there. I scanned chapter 1 and it's in there for you.
Thank you.
So you can use that or you can take pictures tomorrow. Whatever's easier. Else? Don't think about it. I'll come back to you. Other questions or concerns as far as, we have a little bit of time, like 3 minutes, which is what I kind of want usually, and I like to end the class on the bell. Other things that have been, I don't know, causing you lack of sleep. They're like, oh my gosh, math class is crazy. But, yeah.
Is the problem due on Thursday?
It is. Very good. So the review day for this class will be on Thursday. So the plan of attack next week is Monday, we do 1, 7 and half of 1, 8. Tuesday, I don't see you guys. Wednesday, we do half of 1, 8 and 1, 9. Wednesday after school, I have office hours. Thursday, your problem set is due. I'm not going to make your 1, 9 homework due the same day as your problem set. So I'll make the 1, 9 homework due, even though we're going to do it on Wednesday. I'll make the homework for 1, 9 due on Friday. So on Thursday, it's definitely your problem set that is due. And your problem set is all the problems in the problem set from 1, 1 to 1, 9. All in one document. One full document. You don't make separate documents. Entitled PS1, problem set 1. Other stuff for next week. So office hours are next week on Wednesday after school. If you cannot make that and you want to see me, just arrange another time with me. But definitely email me ahead of time. Don't just show up and expect that to be here at a random period. Definitely know, look at my schedule.
So the class is on 1 through 9, right?
1, 1 through 1, 9. Yep. 1, 1 through 1, 9. Don't forget to review the summer packet a little bit. And if you want to ask questions about the summer packet on Wednesday at office hours, that would be a good opportunity to do so. Guys, have a good day.